So we left off in the last video calculating our model's false positive rate, true positive rate, and at what thresholds using the ROC curve function. Now, we kind of got back the false positive rate, but it's in an array of numbers. So looking at this, again, doesn't really make much sense, but plotting it and seeing the ROC curve, the actual ROC curve, will make a bit more sense. What we're going to do is we're going to create a function for plotting ROC curves. Now, in your practice, when you need to make multiple plots, as we saw in the matplotlib section, you might want to create a function that does plots for you if you want to make more of the same plot. So that's what we're going to do here. Just see an example of how we might create ROC curve plotting function. So first of all, we'll import matplotlib.pyplot. We're going to go as PLT, beautiful. And then we're going to go, call it nice and simple, plot ROC curve. It's going to take the false positive rate and the true positive rate. Then we're going to come here. We'll leave a nice doc string so it makes a bit of communicative sense. Plots are ROC curve given the false positive rate FPR and true positive rate TPR of a model. Wonderful, nice and simple. I'm going to go plot ROC curve plt.plot. We're going to pass it the false positive rate and the true positive rate, and we'll give it a color score. Got to remember that these libraries take American spelling. We go here, orange, and then label equals ROC for ROC curve, and then we're going to go plot line with no predictive power. This is going to be a baseline. You'll see it when the plot comes out. It'll make a bit more sense. That way we can compare our model to some other arbitrary model which just predicts nothing. 0, 1. Wonderful. And the color is going to be dark blue. Line style, we'll keep it dotted. Actually, this is only 2, so it looks different to our ROC curve. And the label is guessing. So this line you'll see when we plot it is basically like our model was just guessing. And then we're going to go customize the plot. plt.xlabel. This is going to be the false positive rate, FPR. And then we're going to go plt.ylabel. You might be able to guess what this is. This is the true positive rate. This is because we got FPR as the X label. And TPR as the Y data. True positive rate. And then we're going to go receiver operating characteristic ROC curve. Now, this is the type of plot you might give someone when they're asking for the ROC curve, right? So this is why I'm showing you this. Plot.show. And you'll probably also come along this sort of plot when you have a look at different classification problems online. They might use the ROC curve as an example of how the model's doing. We want FPR first, TPR. Beautiful. So this should work. Wonderful. What is going on here? We finally get to see what a ROC curve looks like. If we go to here, if the false positive rate is 0.6, the true positive rate is going to be 1.0. So the maximum score it can get is 1.0 up here. And so this model here, going from corner to corner, is guessing. Can you guess where the most ideal ROC curve might end up? If this is guessing, and our model is doing far better than guessing by getting about 80%, 85%, 82%, something like that. Can you guess where the most ideal curve will go? That's all right. If you can't, what we're going to do is have a look at it. So before we do actually is let's have a look at the AUC score. We can do this from Scikit-learn import ROC AUC score. And so this is where the AUC comes into play from ROC. So when you hear area under curve or receiver operating characteristic, what is AUC score? And so we can do that. Let's just see it in action. This takes the test labels as well as the probabilities. Oh. So we can do Y probs. Oh, we need positives. There we go. So how did I know this? Again, docstring, Y true, Y score. Wonderful. And so what is this metric, you might be asking? Well, this is, remember, AUC stands for area under curve. And so if we were to calculate, take our curve, ignore this one for a second, let's just get rid of that. So if we were to take our curve, this here, it's a bit of a jagged curve, but it is a curve. And if we were to measure the area, so shade in everything under here, shade in all of this, and figure it out, then we've got 1 across here, we're missing some space up here, so our area is definitely not going to be 1. Our score is going to get 0.84, so 0.849. Now the maximum score you can get, can you guess, with an AUC score? So area under the curve. The maximum score you can get is 1.0. And so that means that the curve goes straight up here to this corner and straight across here to that corner. Now let's see it in action. So if we're going to go plot perfect ROC curve and AUC score. So we're going to go FPR, TPR thresholds equals ROC curve. Go Y test. Then we're going to go plot. We're going to use our function here, ROC curve. See where it comes in handy because we want to plot multiple ROC curves. TPR, FPR, TPR. Let's do that. So this is a perfect ROC curve here. The area under the curve here, can you guess what it would be? We just discussed it. So perfect AUC score is ROC AUC score Y test, Y test. Now that's 1.0. And so in reality, a perfect ROC curve is very unlikely. That means you've got a perfect model. It's got no false positives, or everything's a true positive. If you saw a 1.0 here as a ROC AUC score, is that going to sort of maybe raise a flag to see if your model is predicting the right thing? The main details here that a ROC curve is predicting is the true positive rate versus the false positive rate. The main metric you can use to boil it down, rather than just being a curve, you can use the AUC score. So that's what you do to calculate a ROC curve if someone asks you to calculate a ROC curve for your model, and it's going to compare the false positive rate versus the true positive rate. So now we've seen ROC curves and area under the curve. Let's have a look at the next classification metric, or the next way to evaluate a classification model, and that is with a confusion matrix.